A rectangular sheet of paper with sides 1 and root 2 has been folded once as shown, so that one corner just meets the opposite long edge. What is the value of D? Well, let's imagine unfolding this piece of paper. So return it to this. Now this length is root 2, which actually means this folded part here is also root 2 because it moves down to there. So that's useful because now I can apply Pythagoras' theorem on this bottom right triangle. Root 2 squared is 2 minus 1 squared, which is 1, gives me 1. I square root that, I'm going to get another 1. And this must be an isosceles triangle, 45-degree angles here. That leads to this one being 45 degrees and this one. So I've got another isosceles triangle and the length must be D. But we can see that the whole length is root 2. That red length that I calculated was 1. So therefore D must equal root 2 minus 1. And we're done. So it's all about unfolding it and then it works out really nicely. Now I don't think you can do this question without spotting that, without unfolding it and realizing that length was also root 2. But you can do it if you don't spot the isosceles triangle. So I'm going to share with you an alternative method now. Again, I'm going to draw this in. This is root 2. This then at the top is 1 minus d, that top length. This length is root 2. And then again, I'm going to use Pythagoras' theorem and say that is 1. And therefore that length will be root 2 minus 1. Well, I'm going to take a slightly different approach now. I'm actually going to work out this length. Well, I'm going to call this x and work it out in terms of d. X squared is going to be d squared plus root 2 minus 1 squared. That's one expression for x. But what I could also do is apply Pythagoras' theorem on this top left triangle and get 2 plus 1 minus d all squared, square rooted. And then I can work out x squared in a different way because it's going to be 2 plus 1 minus d squared when I square the hypotenuse. By the way, I'm now dealing with this like green triangle inside here. And then I will minus root 2 squared. Actually, that's just going to give me 1 minus d all squared. And because x is the same for both, I can just equate the two together. It must be that d squared plus root 2 minus 1 squared is equal to 1 minus d all squared. Let's expand the brackets. D squared plus 2 plus 1 minus 2 root 2 is going to equal 1 minus 2d plus d squared. The d squareds cancel, the 1's cancel. I can rearrange it so it's 2d is equal to 2 root 2 minus 2, and therefore d is root 2 minus 1. Of course, this is much more complicated than the first method, but it does all check out without me using that isosceles triangle that was here on the bottom right. Okay, well done on this challenge and on this question. Keep going.